Welcome everyone to our lesson on differentiation. But in this lesson, we will tackle tangents. Okay, tangents. To help us understand tangents, let's consider this curve. So we have our x and y plane, and then we have our curve called f of x. All right. Now a tangent is a line that touches a curve at one point. Okay. And another line that crosses the tangent at a 90-degree is called a normal. All right. So I've done a separate YouTube video on normals. So you can check my channel for the video on normals. So for this one is mainly for tangents. All right. So I've defined tangent as a line that crosses or touches or intersects a curve at one point. Okay, so I need you to understand something here. We have already covered the lesson, the introductory lesson to differentiation, dy dx. So you can check that video on my channel. So if the value of dy dx or the gradient at the point x1, y1 is m, then to find the equation of the tangent, it must be of this form, okay? Where m is the gradient that you will find from differentiating the curve. Then this x1 comes here, and then the y1 also comes here. So you need three things. One, the gradient. Two, the x value of the point. Three, the y value of the point. Okay, so let's start with the first example. We are to find the equation of the tangent to this curve at this point. Okay, so what do? The first thing we do is to differentiate the curve. So dy dx will give us 6x squared plus 10x. All right, but we need to find the gradient of this curve at the point x equals 1. So we will put x equals 1 into this gradient function to find the gradient. Now when we do that, we get the gradient to be what? 16. Okay, so I told you we need three things. We need the x value, we need the gradient, and then we need the y value. So to find the y value, we will put the value of x into the curve to find the y value. So let's do that. So we put the value of x, which is 1, into the curve, and then we get the y value to be what? 6. So our job is basically done. We have our equation. So the y comes in place. The 6 will replace the y. The 16, which is the gradient, will replace the m, and then the x, which was 1, the 1 will come and replace the x1 here. Okay, so that's what we will get. So we have y minus 6 is equal to 16 into x minus 1. Okay, so this 6 is replacing the y1, the 16 is replacing the m, and then x equals 1, which was given to us, is replacing the x1. Then we will simplify this, and then this is what we have. 16 times x is 16x, 16 times negative 1 is negative 16. This is minus 6, so it becomes positive 6 here. And then we simplify. So we have y is equal to 16x minus 10. So this is the equation of the tangent. You see, very, very simple. Let's see the second example. Right, so we have this. We are supposed to find the equation of the tangent at the point P. But what is P? So let's go and consider the entire question. So the tangent to the curve y is equal to 3x squared minus 10x minus 8 at the point P is parallel to the line y is equal to 2x minus 5. All right. So we need to understand a few things. One, if we are told that a curve and a line are parallel at a particular point, then it means that this parallel suggests their gradients or gradient functions at that point is what? Equal. So you can write parallel is equal to equal, all right? Or parallel means equal to help you understand this. Okay, so we start. So this is the curve, this is the line that are parallel at the point P, all right? So we said that their gradients are equal. How do we determine that? So we will differentiate this curve and then we will differentiate this line and then equate their gradient since we said they are equal. So when we differentiate the curve, we have 6x minus 10, and then the differential of this line is 2x. So we will equate them, and then we will get 6x minus 10 equals 2. Then we solve for x. X will be equal to 2. All right? Okay. So we would need to find the y value. Okay? We will need to find the y value. Why? Because the curve and then the line are equal at the point P, and point P will have both x and y values. So to find the y value, we put the value of x into the curve and not the line. Why? Because we are looking for the equation of the tangent to the curve, not the equation of the tangent to the line. All right, hence we'll put the value of x into the curve, and that gives us negative 16. So we have the gradient, which is 2, we have the x value, and we have the y value, so we can find the equation of the tangent. Right, so the equation of the tangent is written of this form. Sorry, this is supposed to be negative 16, not negative 1. So we know the y value to be what? Negative 16. We know the x value to be 2. We know that the gradient is 2. Okay, so we can find the equation. So we just substitute those values into our general equation formula, and then we are good to go. All right, so 2 times x will give us 2x. 2 times negative 2 will give us negative 4. Negative times negative will give us positive 16 here, all right? But we send it to the other side of the equation, so that becomes negative 16. And then we simplify, we will get y is equal to 2x minus 20. So this is the equation of the tangent to the curve at the point P, okay? All right. So what is the summary of what we've done? The first thing is that know that parallel means they are equal, okay? Then we differentiate both the curve and then the line, and then we equate their gradient functions to solve for x. Now, given the x value, we put into the curve to get the y value. Then we form the equation of the tangent using the general formula y minus y1 equals m into bracket x minus x1. Now I want you to try this. You are to look for the equation of the tangent to the point, to the curve x minus 1 over root of x plus 1. Okay, at the point where the curve cuts the y-axis. So I'm giving you a few hints. Now this is a function dividing another function. So use the quotient rule to find the gradient function. Okay, so use the quotient rule to find your dy dx. Now another thing in the question is that the curve is cutting what? The the y-axis. So the clue is that at the y-axis x equals 0. So when you differentiate and you find your dy dx, just substitute x equals 0, and then you'll be able to find the gradient. Then you put x equals 0 into this curve to find your y value. Then you proceed to find the equation of the tangent. Your answer should be this. So if you get it correctly, you should get y equals 9/16x minus half.